everyone. Welcome to HBase Tales from the Trenches. Self-introduction, my name is Wellington. I work at Cloudera as a software engineer. I've been working with HBase for a few years now. And today's session is a sampling of common support issues that has come into us from our customer base over these years. Going through a summary of what we'll be covering here, with the first 3 bullets will be defining and explaining a bit what are these common types of problems. And then I had sampled a few common support, repetitive support cases, with descriptions of the issue, and which of these, among these types of problems, we're classifying which of these issues are, which HBase subcomponent or third-party feature is affected, the reasons, some quick insights on the recovery and the resolution, and some tips on how to mitigate those problems as well. And we'll finalize with some general best practice to avoid these common issues that normally see on for different deployments. Talking about which are these common types of problems, we could basically, taking a report from our support tickets database, we could classify this as one of these 5 main topics. The first one, region servers or master crashes, roughly relates to 20% of our support tickets. The second major types of problems are classified as performance. Those are the typical tickets coming as my HBase is slow, or my HBase application, my application reading or writing to HBase is slower than usual. A third large amount of cases come described as regions stuck in transitions, also known as RIT. These are responsible, I would say, from reports that I took for around 10% of our cases. Surprising as well, there are a fair amount of cases that come complaining about file system usage exhaustion, where HBase is taking over almost entirely the entire space of the underlying file system. Less common, from what I see, it's around at most 5%, but there are some cases reporting corruption, data loss, or replication data inconsistencies. Decided to bring this over in these examples that we'll be showing today, because even though those are not very common, I think it's, given the criticality, is worth mention and showcase those as well. So from the common types of problems, the most affected features are subsystem or even third-party components. We could list assignment manager, usually related to performance and reads related cases. Replication, of course, would be related with replication consistency issues, but also could be involved on the mentioned file system usage exhaustion. Region server memory management, which is basically leveraging critical component from the JVM, the most one involved with performance-related issues, but also could be behind process crashes. Master initialization, which is a feature, also very often is the one involved with both performance and process crashes, if we're talking about master crashes. WAL store file will be the ones involved with the unusual corruption issues and data loss related tickets that we deal with. And then, like the last bullet here, highlighting custom applications, filters, co-processors. These are usually third-party components or processes that either plugged into or interact with HBase. Those are usually behind the reported performance issues as well. Common reasons for each of these common types of problems. Within performance, we're normally dealing with overloaded cluster or underdimensioned cluster, where the amount of requests reaching the region servers is too high for either the region server configuration itself or for the number of region servers in the cluster. Those could also be related to non-optimal configurations. That there are many tunings, there are many specific knobs on HBase configuration that allows for customizations, and if sometimes those are changed without a clear understanding of the impacts, and some changes that might optimize a specific workload might then impact on different workloads. So changes that are made with the intention of getting a better write performance could then impact on the read performance. Crashes normally caused by memory exhaustion. Then I would say it is as well tightly related to performance common reasons as well. Like if we have region server with non-optimal configuration, for instance, for heap size, that could be behind the common crashes. But it's also could happen to the underlying file system issues, unavailability on the underlying file system, even temporary could cause either region servers or masters crash. It can also happen due to known bugs. Most of those already fix it, but if you are in a release that doesn't include the fix, it will be affected by those problems. Read reasons also affected mostly by known identified bugs that if you're in a release that doesn't include the fix would then surface this problem. Could be self-induced. We've seen very common support tickets where prior to reaching our support service, the customer operator tried on their own to fix some problems that they are seeing with HBCK commands, and without understanding properly the outcomes of those, they ended up getting to a state even worse than the original issue was. It can also happen as a side effect of performance. If you have performance causing crashes, so that region transitions will occur very often, that will increase the likelihood of reaching conditions where the assignment manager can't really find available region servers to online the given region, or the remaining online region servers will be already so exhausted that a simple region assignment operation would take longer than some configured threshold, timeout threshold to complete. That will cause a region, for instance, to enter a state where it requires manual intervention. File system usage exhaustion, normally caused by poor snapshot retention policy or replication-related issues, either replication not performing or not executing properly due either issues with peers, infrastructure, but also can be due to poor management of a replication service. For instance, we've seen cases where operators just pause replication indefinitely and didn't realize that would cause file accumulation in the source. and then to the point where they just realized the problem when alerts about available space started to get triggered. Corruption data loss or replication data inconsistencies, those are most often seen with bugs on the storage layer of HBase. Could also, in the case of replication, as Charlie mentioned on the other bullet, could be due faulty peers or even infrastructure, or also could be caused by custom or third-party components in terms of coprocessors or filters plugged into the code path. Could also be related to the underlying file system problems. That's normally when we see data loss. If corruption happened at the underlying file system error, there's very little that can be done from HBase perspective to recover or getting back the data that was lost at this point. Going to the second part of the presentation, then we'll be showcasing some of the common case descriptions that can be classified as the previous shown case types here. First one, typical performance or process crash case. Described as region servers is slow, crashing randomly. This is actually a common case title on support tickets. Feature affected here could say it's the region server memory management. So this is one of the most common performance / process crash issue where we see the main reason here is that HBase region server heap size is too small for the workload, and we typically see first if you're lucky, we see like long GC policies but no crashes. In the worst case scenario, we see the region servers simply crashing due out of memory errors. So diagnosing those would go through obviously the region server logs, either the region server process logs or the region server standard output log as well. So these are different files. These are the first place to try identify underperformance, but also taking a look at general stats for the cluster, like regions per region servers and JVM heap usage or garbage collection activity charts, either taken with the standard monitoring tools provided within JDK or your preferred monitoring tool, either like Cloudera Manager or Embari. Resolution for those typically consists of incrementally increase the heap according to the workload and see what are the outcomes from these increments. As you get to some specific heap sizes, generally above 220 gigabytes of heaps, CMS, which is the full garbage collection within the JDK version, default JDK version for HBase, can start to experience some slowness. From there, we generally start to recommend some experiment with different garbage collection implementation, typically due one. There is already standard recipe of configuration tunings for G1 published on this Cloudera engineering blog post that had provided good results in most of these cases. Horizontal scaling by adding more region servers and spread the load in order to release pressure on the individual region servers is obviously another possible resolution for such cases. Next case story describes a situation where we see slow scans or compactions taking longer, and like single compaction activity taking longer to complete, and causing other compaction requests to pile up on the compaction queue. These were due to a specific issue with prefix tree H file encoding type. This particular type of case was very common in a specific geographic region where, for some reason, our customers in our customer base were applying this specific configuration. Diagnosing that was typically, obviously, the first symptom perceived was slowness on either client scans or compaction, with compaction queue getting higher. And then by taking JSTACs of the region servers where the scans were running or compactions, delayed compactions running, would typically show this code path being executed over and over and progressing very slowly. Resolution for those is not straightforward, unfortunately, because it requires a table disable, which means the table data will be unavailable for some time, and then if you have compaction tool or the offline compaction tool available, perform manual compaction of those files. That will be compaction running outside of the region server. It wouldn't be faster than the region server compaction, but at least would release the pressure from the region server so that it could perform well other requests. And then finally, once it's finished, completely disable prefix tree encoding. The mitigation for that is don't use this feature. It was stable and not maintained, and at least from 2.0 onward, it was dropped. So if you ever plan to long-term HBase deployment upgrade to newer versions, we will need to give it up on this feature anyway.
Which encoding is recommended going forward?
We don't recommend any specific. Yeah, just use the default. Yeah, just use the default. Don't recommend any custom specific. Third common case description, getting to us over and over, is that my HBase is slow. Typical performance issue. This is usually happening for varying reasons. The three most commons are either dependency services underperforming, like we see problems with Zookeeper or HDFS. The underlying file system is not providing, it's not responding fast enough for HBase requests. Can also happen for poor client implementation. So very common, we see client applications not reusing H connections, so creating a new connection over and over, and that would bypass, for instance, the caching of regions that it first gets from metatable. Other issues that we see here is faulty coprocessors or custom filters. So those are usually plugged into the code path, and then since it doesn't have control, it was not controlled. The implementation is not controlled by HBase controlled release. It could very well have introduced issues into the normal flow. Diagnosing those issues generally include taking both client applications and region server JSTACs to try identify what is the typical code path being executed during this slowness period, or whatever activity that is taking longer than usual or the perceived normal to complete. But also keep monitoring the general HBase stats, such as compaction queue size, data locality, cache hit ratio. Those are things that maybe could benefit, could get a increased performance if there are some the values observed here are not optimal. And also for situations where the issue relies on dependency services, HDFS or Zookeeper logs would be the normal other important source of research as well while troubleshooting that. Resolution as well will vary according to the specific reason identified while diagnosing those. Those could vary from tunings on dependency servers or even on HBase itself, for instance, for a case of data locality or cache hit ratio, but also could imply a redesign of a client application, rewriting a client application, or if you, in case, if JSTACs, for instance, reveal that the slowness coming from custom plugged co-processors or filters, that will be that will require re-implementation of those as well, or at least a review of whatever is stuck in getting HBase stuck for some reason. Another case story. This is an example of common read support cases. Feature here is usually involved is the assignment manager. Again, this is also can happen to various causes, such as already mentioned before, misuse of HBCK, like executing commands that are not, which the outcomes are not well known. A common problem as well is involving snapshots, snapshot straightedge, for instance, using snapshot code backups where required files for snapshots are taking off the underlying file system, like HDFS, for instance. And then when these snapshots are recovered, these required files were forgot and were not brought back together to the underlying file system. And then the clone table, the table recovered from these snapshots, is starting to see problems to get its regions online. Another common reason for that is a busy or overloaded cluster with regions moving constantly. That will be, even if these regions don't get stuck in transition for a long time, there will be a perceived unavailability from client applications or monitoring tools. So it's common to see cases coming, well, there's this amount of regions in transitions, and then when you log into a screen share of a customer, there's either known or a completely different subset of regions in transition. So that's a case where there's what we really need is tuning or horizontal scale or tuning the region servers so that regions don't keep transition that much or don't need to be moved around different region servers. The path for diagnosing those is using the HBCK tool or master web UI. Like these are the most useful feature tools for such issues. Once it's detected once specific regions are detected to be constantly, infinitely stuck in transition, then the normal path is go through the master logs, try to identify at which region server the assignment manager is trying to open that region, and then go to that region server log, and if it is some error happening while some exception happening while processing the assignment on the region server, that will be somehow evident on the region server logs. But even there are situations where there's no exception happening, and then the next resource would be to take several JSTACs and try to, from the JSTACs, would be able to see the code path being executed by the open region threads, and that would then give some further insights of what else to check or which subcomponent to check. Resolution is, there's no single recipe because there are different, there are many different types of regions in transitions that we couldn't actually cover here. So the resolution generally resorts to a combination of HBCK and HBCK2 commands, HBCK2 in the case of running on Hadoop 2.0 onwards. But unfortunately, it's hard to give a single recipe for all that would work for all these different read type of problems. Another common type of support case is the master timing out during initialization. This is a typical master crash, or could also say service outage if coming from a complete full cluster restart. The feature here is a master initialization. There are different bugs that could be related to this problem. For this specific type of case, what we normally see is a problem with the procedures subsystem. These different bugs could cause an accumulation of procedures under this directory, and whenever master restarting, it needs to load the procedures that are stored on files under this directory in order to replay and resume the stage where the different procedures, different processes running over HBase were happening while master last restarted. In this specific scenario, what we see is that there are so many of these procedures to be replayed, to be resumed while restarting, that master just gets into a timeout, initialization timeout, before it can complete. A typical resolution from our support team here is to get rid of all the files on this folder and then restart master, and simply having all the procedures that were ongoing to be bypassed. That's a valid fix for whenever you see this issue on HBase 1.x release versions. Wouldn't be very secure to do that on HBase 2.0 onwards, but luckily we don't see this type of problems yet on HBase 2 release line. For mitigation, increase the initialization timeout for master so that master can, even though it takes longer to complete, still it would not crash while trying to resume the procedures. Another typical workaround that helps with those problems is increase the number of open region threads. That would speed up procedures that rely on regions assignments, because now we have more workers capable of doing the requests that comes from master initialization. Another case example, replication lags. These are the type of replication stuck type of issues. Feature obviously replication. Reason here, in this specific example, we see quite a fair amount of cases coming with this problem where, for some reason, the ingestion was designed poorly, where it was batching up too many operations in a single RPC entry, and eventually that reached this property, which is a threshold for the call queue size. So typically, when diagnosing these, you see at the destination peer region servers these type of log warnings repeating over. And resolution here, normally it's not straightforward. It will require for a complete reset of replication configuration and manually copy of whatever records came into source after the issue started to get observed, because basically you need to clean up replication state and reset everything from scratch, and then everything that came after the problem start to be observed until the fix is applied needs to be processed manually in the destination peer. This issue is solved by this HBase Jira. So if you recommended is to get into release that include this fix, that will avoid this problem completely.
Which version includes that?
If I'm not wrong, 1.5 something. I have to check my notes, but it is backported to some of the branch 1 releases. Another one is client scan failing on specific regions. This is H file corruption type of problem. Seeing a fair amount of those happening as well, affecting the store file. The reason is an unknown bug with snap compression. Snappy is a library that can be used in HBase to compress H files. And typically while diagnosing, what we would see is these kind of errors in client scans or everything else that tries to read the given affected H files. And the only resolution for those are sidelining the affected files, and if you can't, and to recover the data is actually requires re-ingest all the records from the row key range that was stored on that file. It's critical. There's a potential for data loss on those. It's not very common, but there is a few numbers of customers that got affected by that problem.
Have you ever seen that happen in the block cache? Because we had that happen once and it went away after a while.
Not in the block cache.
Repeat the question.
Yeah.
I was wondering if this could happen in the block cache.
Yeah.
That went up for us once and it went away.
Yeah, I need to repeat the question. So the question was if we ever saw this happening at the block cache. The answer is no, but if block cache is is also compressed with Snappy, it's very likely that that could happen. We don't really know yet the cause for this issue. That's why it's classified as unknown, because there is, as far as I could track, I couldn't find any open Jira with the fix for that. And it's the conditions where that causes this to appear is hard. We couldn't actually reproduce it. We could observe it, but never managed to reproduce what caused the problem. Then, like, among the type of issues described first, this is the file system usage exhaustion. Could be caused by different features here, like replication, snapshot, compaction not happening, or cleaners not running. So those are the various reasons that could get into this situation. Diagnosing those is basically involved check the archive folder for H files or old walls folder for wall files. If those are the ones that are responsible for most of the space usage from HBase, it's very likely that you're facing that because a problem in one of these highlighted features. Diagnosing it, once you identify that these are the folders where most of the files are residing, master logs would be the first source of research to identify if there are any exceptions that cause the cleaner threads to stop running. So you would be able to see exceptions coming, and in the stack trace, you would see that those coming from from the cleaner thread code path. If everything is if everything is clean on the master logs, take a look. Use some of the tools about replication. Take a look at replication status and see if it's reporting lagging or over time the point where replication is reading the wall is not progressing. Another thing that is, if you mainly see most of the usage coming from the archive folder, take a look at snapshots, how many snapshots you have, and how many snapshots, for how long are these snapshots being retained on your system. And resolution here will vary according to the specific region. From, if you identify that cleaner threads, you saw some exceptions that aborted the cleaner thread. A simple master restart will cause the cleaner threads to run again. Disabled peers, for instance, if you see a lot of files accumulating in node walls, take a look at the current state for the peer. If the peer is not disabled, which would basically pause replication. So re-enabling the peer again would allow it to resume. Or if replication is not really wanted, we could just remove the configured peer, and that would quickly get rid of the extra old walls files. In case of too many snapshots, review of your snapshot retention policy is required. For replication lags related issues, there might be many reasons. We just saw a few slides back one specific case that was related to an issue on HBase that is mitigated by a fix already provided on some releases. To finalize, general best practices to mitigate or avoid completely these issues is keep monitoring heap usage, keep regions per region servers on the low hundreds, consider G1 DCs if you start to require heap sizes larger than 20 gigabytes. Pay extra attention to data locality, see if your performance issue might be related to poor data locality. Adjust caching according to the workload. So if you're having, if your workload is most critical for reads and you're having problems with read performance, consider increased block cache over main store, or the opposite if you have a write workload, more sensitive write workload. Compaction policy as well. Useful feature that I was already mentioned before is the compaction tool that would release, that will perform compactions and outside of the region server process. So compaction is a very resource-heavy operation. So it will release a lot of resources from region server by doing that in a way we call offline using these compaction tools. Zookeeper as well. Consider an exclusive Zookeeper service for HBase. Zookeeper could be affected by other services if it is if same Zookeeper services is used by multiple services. That could affect Zookeeper performance, and that could impact on overall HBase behavior. For cases where you have problem with master initialization process, consider increase the timeout or the number of open region handlers to avoid master crashes during initialization. For space exhaustion, review your snapshot rotation policy if you're using snapshots. Be cautious with experimental non-stable features. Those will be the advice for the snappy or prefixed tree issues showcased here before. Define deployment policy for custom applications, coprocessors, or filters. It will be surprising the amount of cases that we see coming because, we just deployed the new thing, and yeah, did you see this happening in your test or stage environment? Oh, yeah, we don't have it. Define also schedule for bug fix upgrades in order to get the benefit of releases that include fixes that would mitigate some of the issues that we saw here. And that was it. Thank you very much. No questions?